Hi everyone. This morning or today's video has us continuing determining if functions are linear or nonlinear. Last video showed us functions in the form of an equation and as a graph. I feel as though we did very well with the graphs. Pretty simple, a completely straight line, no bends, curves at all, are linear functions. Anything that curves or changes direction in any way is nonlinear. We did great with that. Unfortunately, I felt as though we had some trouble with the equations. And it's really quite simple. I think you were overthinking it. Linear functions look like this: y equals negative 7x plus 9, or y equals negative 3. This would be a horizontal line. This would not be, but notice the exponent on the x is a 1, or there's nothing written there, and we know it's a 1. Whenever that happens, it's a linear function. Whenever there is an exponent that's something other than 1, 2, 3, x, 1/2, whatever it might be, that's when it's a nonlinear function. Other things that kind of demonstrate nonlinear functions to us: if we have a fraction, but the variable's in the denominator; if we have a square root symbol in our function rule, but it has to be over a variable. It's all about these symbols with the variables. If there's an exponent in the variable. I'm going to show you a few more examples to help you truly understand this, and your homework assignment for this will include determining if equations are functions again. So here we have just two columns, linear and nonlinear. Okay, y equals negative 3, horizontal line, that's linear. Y equals negative 3x plus 8, the exponent on the x is a 1, it's linear. This one right here is a little bit tricky. I do see an exponent other than 1, but notice it's not on the variable. We have y equals 5x minus 2 to the third power. If you remember, 2 to the third power is just 8. So this is really y equals 5x minus 8, just written in a different format. So this is still linear. Y equals 3/4 x plus 7, linear. Exponent on the x is a 1. Y equals negative x minus 4, linear. The exponent on the x is a 1. Y equals 1/2 x, linear. Exponent on the x is a 1. Y equals 4, horizontal line. Y equals 7x, linear. Exponent on the x is a 1. Notice in all of these, there's no exponents on any of the variables, linear. Now come to the right-hand column here, and I'm showing you a bunch of nonlinear. Y equals x to the 6th power. Exponent on the x is a 6. Y equals 5 plus x cubed. Exponent on the x is a 3, nonlinear. Y equals the square root of x plus 3. Square root symbol over the variable, nonlinear. Y equals 1/3 x to the 4th power minus 8. Exponent on the variable is a 4, nonlinear. Y equals 5 to the x power plus 5. Our exponent is a variable, nonlinear. Y equals 2x squared plus 1. Exponent on the variable is 2, something other than 1, nonlinear. Y equals negative 8x to the negative 2nd power. Exponent on the variable is something other than 1. It's a negative 2, nonlinear. Y equals the square root of x minus 6. Square root symbol over the variable, nonlinear. All of these, I think, become pretty self-explanatory. The more you look at them, take a good look at this chart. You're going to notice that on the nonlinear side, all of our variables have an exponent other than 1, or the square root symbol, or the exponent is a variable. Linear are much easier to spy. They're very straightforward, everything we work with. The trickiest one would be this, but the exponent is not on the variable. That's why it's linear. So now we are going to have to determine if tables are linear or nonlinear. So these are the 5 different tables I'm going to take you through. And we need to determine if these tables represent linear or nonlinear functions. So you just need to determine the rate of change. New word for us, but nothing new to us. The word rate of change is how we talk about the slope of a function. So we use the word rate of change when we're working with functions, as we use the word slope when we're working with linear equations. But they truly mean the very same thing, and we find them the same way. Ooh, that's a little blurry, this enlarged, but that's okay. So the rate of change of a function is the ratios, aka fraction, that compares the difference between two output values to the difference between the corresponding input values. Now, in all of our work with functions, we've learned that output values are your y values, and we've learned that input values are your x values. So your rate of change is your change in the y values over the change in your x values. Better said, y2 minus y1 over x2 minus x1, or rise over run. So when you're finding a rate of change, you're really finding the slope, and we've worked endless hours on that this school year, so we should be very good at this. So here's the first one that I'm going to take you through. Now, I know this is a lot for you to see. Just stay with it. So we have our table. Here's our x values, our y values. It is a function. Remember, our y values is kind of like our rise. Our x values is our run, because our rise is vertical, so that on our vertical axis is our y axis, and our x axis is horizontal. That's like our run. So all you need to do is do just what I did on your tables. You're going to have to take your homework, and you're going to have to write these tables down on paper to work this out. You're not going to really be able to just look at it on paper. So I'm looking at the difference or the change of how it's going on all just the y values right now. So from 5 to 7, it increases by 2. From 7 to 9, it increases by 2. And by increasing, I put the plus sign. From 9 to 11, it increases by 2. So that's my rise. This means I'm rising 2 between each of these points. Come over to the left side, do the same thing with the run. How does it change from 3 to 4? It increases by 1. How does it change from 4 to 5? It increases by 1. How does it change from 5 to 6? It increases by 1. Therefore, I'm going to take between 3, 5 and 4, 7 and write that as our rise over run. We have plus 2 over plus 1. Now between the next 2 points, 4, 7 and 5, 9, it increased by 2, and then it increased by 1. So I wrote 2 over 1. And now between the last 2 points, between 5, 9 and 6, 11, from 9 to 11, it increased by 2. So that's my rise. That goes in my numerator. And from 5 to 6, it increased by 1. So that goes in my denominator. So now you can see that these are all the same. That means my rate of change is constant, or it doesn't change at all. Therefore, it's going to be a straight line. As I go between all my points, I'm constantly going to be rising 2 units, running 2 units, up 2, right 1, up 2, right 1, up 2, right 1, up 2, right 1. When I am constantly going at the same rate like that, therefore, it is a linear function. So my rate of change here would be positive 2. I simply simplified 2 over 1 to 2. And therefore, the slope is 2. It's linear. Here's our next one. We have our table right here. I labeled my y side, my rise, my x side, my run. And I am going to determine how it changes between all my y values, going straight down from 2 to 4, and then from 4 to 5, and then from 5 to 7. From 2 to 4, it increases by 2. From 4 to 5, it only increases by 1. From 5 to 7, it increases by 2. Now you can see this is not the same already. Don't go ahead and automatically assume it's nonlinear. Do the same on the run side. From 0 to 6, it increases by 6. From 6 to 9, it increases by 3. But from 9 to 15, it increases by 6. Take all of your changes in your numbers and write them as rise over run. So from this side, from 2 to 4, it increased by 2. And from 0 to 6, it increased by 6. From 4 to 5, it increased by 1. And from 6 to 9, it increased by 3. From 5 to 7, it increased by 2. And from 9 to 15, it increased by 6. So I have 2 over 6, 1 over 3, 2 over 6. But this truly does all simplify to be the same thing. 2/6 is the same thing as 1/3. So at first glance, when I was finding the difference between my y values, it made it look like it was not going to be linear because I had a change of 2, then 1, then 2. But when I actually wrote it all out, I did notice, though, that it all simplified to 1/3. So our rate of change or our slope is 1/3. And because the rate of change is constant, or it rises 1, runs 3 between any 2 points, it's linear. Our next one. Okay, throwing some negative numbers in here, so you've got to really think hard on this. I've labeled my x side my run, my y side my rise. And now I'm going to find the difference between all the y values from the first two, -7 and -1. I'm actually increasing by 6. -1 to 5, again, increasing by 6. From 5 to 11, increasing by 6. And from 11 to 17, increasing by 6. Do the same over here on the x column or my runs. From -2 to -1, I'm actually increasing by 1. -1 to 0, I'm increasing by 1. 0 to 1, I'm increasing by 1. And 1 to 2, I'm increasing by 1. Take all of your numbers here and write them as rise over run. So between the first two sets, I increase by 6 on my y side, increase by 1 on my x side. Between the next two, -1, and 0, 5, I increase by 6 on my y side, increase by 1 on my x side, or my rise over my run. Between 0, 5 and 111, I increase by 6, then increase by 1. And from 111 to 217, I increase by 6 and I increase by 1. I can see that +6 over +1 is the same all the way throughout. Therefore, my rate of change or my slope for this function is +6, and therefore this function is linear. Now, on this one, again, took my table, labeled my x column my run, my y column my rise. Start with the y's because we do the rise in the numerator. From 5 to 11, I increase by 6. From 11 to 21, I increase by 10. From 21 to 35, I increase by 14. Come over to the left side. From 1 to 2, I increase by 1. From 2 to 3, I increase by 1. From 3 to 4, I increase by 1. Take these and write them as your rise over run. So between the first two ordered pairs here, 1, 5, and 2, 11, I increase by 6 over increasing by 1. And then from 211 to 321, I increase by 10 over increasing by 1. And the last two, 321 and 435, I increase by 14 and increase by 1. These are not the same. 6 over 1 simplifies to 6. 10 over 1 simplifies to 10. 14 over 1 simplifies to 14. Because this rate of change is not constant, or it's not increasing the same amount the whole way through, rising and running the same amount, we can't determine a rate of change because it varies throughout the function. We will call it nonlinear. And the last one I'm going to take you through. I forgot to label my run and my rise, but you should be doing that. My x column is my run. My y column is my rise. Now find the difference on my y column. From -5 to +2, I increase by 7. From 2 to 7, I increase by 5. From 7 to 14, I increase by 7. From 14 to 19, I increase by 5. Now do my x column, -2 to -1, I increase by 1. -1 to 0, I increase by 1. 0 to 1, I increase by 1. 1 to 2, I increase by 1. Now take all of these and write them as your rise over run fractions. +7 over +1. +5 over +1. +7 over +1. And +5 over +1. Now, is this the same all the way throughout? 7 over 1 is 7. 5 over 1 is 5. 7 over 1 is 7. 5 over 1 is 5. even though I kind of see a pattern, it's not the same throughout. It's going to kind of rise a little, then rise more steeply, then rise a little again, then rise more steeply. Therefore, it's nonlinear because it's not constant throughout. I hope this helps you. You now have a homework assignment. You have 10 questions where you just have to determine if the equations are linear or nonlinear. And then you have 3 tables where you have to determine if they are linear or nonlinear. If they are linear, you have to tell me what the rate of change is. If they're nonlinear, you just state nonlinear. Now, the tables are going to be a little tricky because you can't write, or you can write in my document. You can type in there, but you may want to copy them down on a sheet of paper and really work them out that way, and then just put your answers back in. I'll know if you're right if you come up with the correct rate of change. No worries. Feel free to ask me questions at any point in time through email or Hangouts. We can schedule a Google Meet if we need to. I hope to see my periods 3 and 5 class at my Google Meet at noon today, and I hope to see my 1st and 6th period class for our Google Meet at 12:30. Please bring any questions you have. If you have a question, I'm sure many others feel and have the same question. Have a great day, guys.